Measuring and layout tools. Learning objectives. At the end of this presentation, students should be able to describe the parts of a tri-square and sliding T-bevel, explain the application of the sliding T-bevel to transfer angles to a piece of stock, explain the various applications of the tri-square in furniture making, and explain the use of a framing or builder square in the workshop and beyond. Now, the measuring and layout tools that will be addressed in this presentation are the tri-square, the sliding T-bevel, and the framing square. Now, let's look at the tri-square. This tool is used to check A, the squareness of surfaces and edges, and B, to lay out lines perpendicular to an edge. So diagram A shows you how the tri-square is used to check the squareness of surfaces and edges, while diagram B shows you how the tri-square can be used to lay out lines perpendicular to an edge. Now, a tri-square has a broad blade made of steel or brass as shown that is riveted to a wooden handle. The inside of the wooden handle typically has a steel or brass strip fixed to it at precisely 90 degrees to the blade. Blades have either metric or imperial measurements. A variation of the tri-square is what is known as a combination square. And so a combination square is a tool used to carry out multiple purposes in a woodwork shop. At its minimum, the tool is composed of primarily two parts, a rule and a head, as shown by the diagram. Now, the squareness refers to the primary use of the tool. In this case, it is used to measure the accuracy of a right angle or 90 degrees. A combination square can reliably measure, therefore, 90 degrees and 45-degree angles. The 45-degree angle is used commonly when you're laying out miter joints. And as we can see by the diagram shown, we are seeing the scriber, the spirit level, attached to the head, lock nut, and also an attachment to the head, a 90-degree square, the slotted channel on the rule that allows the head to move, and there's a 45-degree miter square section that is also designed with the head to help the user to establish 45-degree angles. Let's look at the sliding T-bevel. Now, the T-bevel or sliding T-bevel has an adjustable blade, making it possible to transfer an angle from one place to another, as can be seen. The handle is usually made of wood or plastic and is connected to a metal blade with a thumb screw or wing nut, and the diagram shows you the position of the wing nut. The blade pivots and can be locked at any angle by loosening or tightening the thumb screw. The procedure for usage is to set the T-bevel from an existing angle, such as from a protractor, etc., and then transferring the tool for duplication of the angle onto a wooden surface. Let's look at the framing square. Now, this consists of a large arm and a smaller one, which meet at an angle of 90 degrees. It is available in steel as well as in aluminum. The wider arm, called the blade, is 2 inches wide, while the narrower arm, known as the tongue, is 1.5 inches wide. The diagram shows you the position of the tongue and blade of the framing square. Now, in terms of use, the square has many uses, including laying out common rafters, laying out hip rafters, and laying out staircases. On the newer framing squares, or what are known as carpenter square, there are degree conversions for different pitches and fractional equivalents. So it's really a versatile tool to have in the workshop because it has multiple uses. This ends my presentation, and these are my references. Thank you.